Now let's talk about viscosity. Viscosity describes a fluid's internal resistance to flow and may be thought of as a measure of the fluid friction. Viscosity is a measure of the resistance of the fluid which is being deformed by either stress or extensional stress. In everyday terms for fluids, viscosity is also called the thickness. So water is thin. So in this animation, if one side is water and the other side is paint or honey, we say that the water is thin, and that basically implies that it has lower viscosity, while honey is thick. That means it has a higher viscosity. So it's the resistance to the flow. So all real fluids have viscosity, which is fluid friction. This implies that pressure difference needs to be maintained across the ends of a pipe for the fluid to flow. Viscosity causes the existence of a viscosity gradient across a pipe, and fluid flows more rapidly in the center of the pipe and more slowly close to the walls of the pipe. The volume flow rate for laminar flow of a viscous fluid is given by this Pasolini's law, which is given by delta V over delta T equals pi over 8 delta P over L divided by N, or eta, R4, where eta is the symbol for viscosity. So in order to understand viscosity, let's do an example. A hypothermic syringe attached to a needle has an internal radius of 0.3 millimeters and a length of 3 centimeters. The needle is filled with a solution of viscosity 2 times 10 to the minus 3 Pascal. It is injected into a vein at a gauge pressure of 16 mm of mercury. Neglect the extra pressure required to accelerate the fluid from the syringe into the entrance needle. What must the pressure of the fluid in the syringe be in order to inject the solution at a rate of 0.250 milliliters per second? What force must be applied to the plunger, which has an area of 1 centimeter squared? So bear with me here. This is going to be a little bit of a more involved process than what we have been currently doing. So we're going to start at the beginning. So we have a syringe needle with the internal diameter of 0.300 millimeters, which I am going to convert into centimeters at some point, and it has a length of 3 centimeters. And the question gives me my viscosity as 2 times 10 to the minus 3 Pascal seconds. And the gauge pressure that it's giving me, I'm just going to call it gauge pressure, is giving me 16 mm of mercury. Now 16 mm of mercury is not a standard unit, so I need to convert it. And my standard unit is Pascal. Now how do I convert 16 millimeters of mercury into Pascal? And the answer is very simple. I multiply this number with 133.3222 pascals. And that will give me 2133.152 pascals for my gauge pressure. That's going to kind of be important. Okay, now what is actually needed? He is asking me what is going to be my pressure in my syringe. Now how do I find this? Well, I know that delta P is going to be the P gauge minus P vein. P syringe minus the P vein, right? Because that's what I'm looking for. I'm looking for the displacement between the syringe and the vein. Okay, so in order to calculate what the pressure in the syringe will be, I have to calculate what the pressure in the vein is. So this is going to be my gauge pressure, which is going to be the same as my vein pressure, but I still need delta P. Now how do I calculate delta P? In order to calculate delta P, I'm going to use the Pasolini's equation, which states delta V over delta T equals pi over 8 delta P over L divided by eta R4. So I need to rearrange this. It's going to become 8 delta V eta divided by delta T, okay, R4 times L, right? This is going to give me delta P. So all I've done is just rearrange things around. And I'm going to start putting values in. Now note very carefully, nowhere does it give me the delta V, which is a change in volume. However, it does give me a rate of fluid change. And the rate of fluid change that it gives me is rate that it's giving me in question 1 is what? 0.250 milliliters per second. Well, that, if I look at it carefully, I'm going to change my marker color so you can see better. If I was to take this number right here, that is the same as that number here. It is the volume per second. Okay, change in volume per second. So what I'm going to do is I'm going to place that number in here, 0.250. Eta, it gives me an eta, 2 times 10 to the minus 3. It gives me a length, which is 3 centimeters, and I can convert that to meters, which will be 0.03 meters, right? So I can plug that in, 0.03 meters, divided by the internal diameter squared, or actually 4 times, 4 cubed. So this is going to be 0.300 millimeters times 10 to the minus 4 in order to convert it, right, into meters. So I'm just going to place that in here, 0.3 times 10 to the minus 4. Plug that number into your calculator, and you should get something like 4716 pascals. So now I have an answer for my delta P. I also know my gauge pressure, which is the same thing as my vane pressure. So all I need to do is place these values in here in order to get P syringe, which is going to be 4716 plus P vane, which is 2133.15. I add those two numbers up together and I get 6850 pascals. So P syringe comes out to be that number right there. So in part B, it asks what force must be applied to the plunger which has an area of 1 centimeter squared. So I'm just going to do part B here so I don't have to erase it because I need some of the information from there. So what do I need? I need force equals what? I know pressure equals force per unit area. This implies pressure times area equals force. And area that they give me is in centimeters, so guess what? I have to convert it into meters. Once I've converted it into meters, I already know what my P value is. So it's going to be 6850 times the area, which is 1 centimeter, so it's going to be 1 centimeters times 1 over 100 centimeters into meters squared. And you can calculate it to calculate what the force is. And for me, when I calculate that, my force comes out to be 0.685 newtons. But don't trust me, as I always say. Do your own calculations. So make sure that when I do any of these problems, that you do them right by my side, so that if I do something wrong, you're able to tell me.